Welcome to our mini lesson on patterns in rocks and fossil layers. Illinois has undergone many changes. Today we see the topography left by the glaciers, but what lies below tells the real story of Illinois. This picture of exposed bedrock from Starved Rock State Park gives us a glimpse into the past. Bedrock is the term we use to describe the solid rock layers buried beneath the soil. Here in Illinois, the bedrock is made of dolomite, limestone, shale, and sandstone. These are all sedimentary rocks. Sedimentary rocks are formed when layer after layer are piled up over time. Think if we had leaves drop from the trees each fall and every year we added a new layer. Now we do this for millions of years. This is how sedimentary rocks are formed. Like this graphic, each layer of rock tells the tale of the conditions from when the rock was laid down to the fossils of historical life. Just how did we get these diverse layers of very old limestone at the bottom to younger sand and gravel at the top? The theory of plate tectonics is used to explain how the Earth's continents are constantly moving. The Earth's crust is broken into different pieces called plates, just like a jigsaw puzzle. You can see on this picture how the plates come together, shown by the red outlines. Movement of the plates can cause earthquakes, volcanoes, and mountain building. The key to this theory is that the plates are always moving, even if it is slow as your fingernails grow. So what do you think happened to give us such diverse bedrock? Paleogeology is the study of ancient plate movement. The continents we know today look very different than in the past. The first picture represents the Ordovician period, about 450 million years ago. At this time, Illinois was near the equator and underwater. This warm, shallow sea created an environment for many sea creatures and the start of the limestone, dolomite, and sandstone we find in our bedrock. Here's the Carboniferous period, about 300 to 350 million years ago. Illinois is still near the equator. Changing sea levels has land exposed, allowing plants and other animals to live in this now hot, swampy landscape. The sediments created mudstone like shale, siltstone, and clay. This is the time that many plants living here were buried to create all of our coal, a very important fossil fuel for Illinois. This picture is from the Ice Age about 18,000 years ago. Although our position on Earth isn't much different than today, temperatures and sea level continue to fluctuate, causing great ice flows. We're still being impacted by the movement of plates, changing sea level and climates. Scientists predict in 250 million years the plates will form another supercontinent called Pangaea Ultima, when all land masses will be connected together, giving rise to another layer of our geologic history. So paleogeology is cool and all, but how do we know this all occurred? Weathering and erosion are the keys to this evidence. Let's take a look at this simulation. Here we have a simple landform. Can you predict what will happen when we add some water? Let's watch. Water, wind, wear, and freeze-thaw cycles can cause weathering and erosion. You can see how the water is weathering or wearing away the side of our landform. You can also see the soil is being carried away or eroded by the water and potentially deposited downstream. Can you see the three distinct layers? Green, yellow, and the newly exposed brown. We would not know the brown layer of rock or soil existed if erosion had not occurred. These are all the same processes scientists use to read the land and study the underlying rock layers and fossils they contain. How do fossils support what we know about the layers of rock and how they got here? Scientists can determine patterns of how different rocks are formed and where certain fossils may be found. Fossils are formed when living things die and are buried under many layers of water. In this illustration, you can see how the limestone rock layer is put down. An ocean-dwelling trilobite dies and gets buried by the next layer and the next. The fossil evidence supports Illinois was covered by water, as the map shows. Conditions change and a new rock layer of shale is formed. Now a fern gets buried, followed by more layers on top. These layers and fossils support the changing deltas of mud and swamp in this map. Finally, the deposition of sand and gravel from the glaciers buries all the rock layers below. Scientists can look at the rock patterns and fossils to determine how old and when deposits were made. Older fossils are found at the bottom and younger near the top. So take a look around you. Outcrops can be found along the river banks. Look for fossils in some of the rocks you pick up, and even coal mined here, and traveling in rail cars to burn for electricity. All of these are indicators of what Illinois once was and how the layers and patterns of rocks and fossils can tell the story of our geologic past. Thank you for watching this mini lessons on patterns in rocks and fossil layers.